In this case, is there going to be an asymptote or a hole, or both? Because sometimes there are both.
I don't know how you tell from this looking at the negative.
Okay. Anybody?
So an asymptote?
Pardon me?
An asymptote.
There is going to be an asymptote here because we know that what is not defined? Division by zero. Division by zero. So, where would, what happens here? At what point will this equal 0? When x is a negative 2. So when x is a negative 2, at negative 2, 1, 2, I know that, I don't know what this is going to look like, but let's just go with that it could either go like this, and this side will approach whatever, but it cannot be negative 2.
So when the bottom is 0, there's an asymptote? Or
yes, an asymptote.
But if there's two numbers that plug in, then
but if I had, let's say, x squared minus 1, and this happened to be, let's say, 2 x, I'm sorry, I'm on 2x minus 1. Okay. In this case, can I factor these and have f of x is equal to 2x minus 1, and what's in my denominator? It's biting you. What is this?
plus 1 x.
Difference of perfect squares. So what does this equal? X minus 1, x plus 1. Okay, so if I can cancel these out, when I graph this, what will I see? That's where I see the hole. Okay, because can x equal a, at what? X is equal to 1. So if I were to graph this, there's a discontinuous, it's discontinuous there because if I didn't cancel this out, the graph is going to just have a little hole there. But what about at x is equal to negative 1? Can x, if I cancel this out and now I have 2x plus 1, can x equal negative 1?
No, because then it would be divided by 0.
Right. So if x is equal to a negative 1, then this, the denominator is equal to 0, and so then I know that's when I have my asymptote. Okay? So, and that's why you should be able to just look at the graph and say, in this case, I know that there's going to be an asymptote when x is at negative 2 because my denominator will equal to 0. When I factor it, and it could be that there's something right here, but because I can get rid of the factor, then we just say that there's a hole there.
Well, wouldn't it be the negative one that there's a hole? Because we got rid of those factors, then you would have x plus 1. So
This is, sorry, this would be a negative 1. No, I got rid of the negatives.
yeah, but so then if you were to factor that out, right, then x
What do you
would
mean?
have
Wait a minute, wait, stop. Factor what out?
x minus 1. If you get rid of those x minus 1.
Yeah, and so now I
So now you
have 2 over x plus 1.
So wouldn't x have
What?
to equal negative 1? So wouldn't negative 1 be the whole, or would 1
X
be the whole?
is your asymptote. Because at this point, if I plug in when x is equal to negative 1, that's all I'm left with.
And then how do you know that the other one's where the hole is?
Because I had a factor in the numerator, and I was able to get rid of it.
Yeah, I'm just trying to understand how you know. So you could figure
I
out, it
can't-
could be either of those two, but then I'm not sure how you figure out which ones where the asymptote is and which ones where the hole.
Because I could see that there is a factor. If you graph this, let's graph it. Let's see what happens. Yes. Alright, so what am I graphing? I am going to graph. So let's graph this way first. Okay? So I'm going to plug in 2 times x minus 1. Close your parentheses, divide parentheses, x squared minus 1, close parentheses. Okay? All right, is everybody good with that? Yes? Everybody has that plugged in? Okay. And now let's see what happens when I graph it. Okay, so I can see that my asymptote is right here. Mine doesn't show. On some of your calculators, a dotted line appears. And but let's see what happens at x is equal to 1. And my graph doesn't show it very clearly. So I am going to go with, I'm going to go to the second table. And I'm going to punch in, I think this was, actually I have to go back. I'm going to go to x is equal to 1, actually. Let's just plug in what happens when x is equal to 1. And there's an error there. Why is there an error? That's where the hole is.
So,
yes.
So in looking at one of those, whatever x would equal once we factored out the common things in the numerator and denominator, that's the asymptote, and then the other one is the hole.
Right. So if you have a factor, if you have a common factor, one in the numerator, one in the denominator, it's a hole. It can't exist. If I have, and then whatever, so if I cancel those out, what's left is where the asymptote is. Does that make sense to everybody?
Be like those two are the whole, and then if x was -1, that would be the asymptote.
Right. And that's what we should have when we graph it.
The table's messed up on my calculator.
What?
I think the table's messed up on here, because all I ever get is, I can't ever get like a table.
Okay, so let's try it just one more time. I hit second, and then table set. Oh, no, sorry. Second table over here. And mine has an error because, I'll tell you why. I'm going to go back to second table set, and in mine, I have mine on ask. So I can ask the independent value, like I wrote, well, what is x equals 1? So if I want everything to show up, I'm going to move my cursor back to auto.
Then normally, I always get decimals.
If you put it as start -3 instead of start -3.52, you get whole numbers.
Yeah, my table set was both on ask, so I wasn't doing it.
There you go. Okay, it needs to be on auto. So it will give you this. If you ask, you're looking for something in particular, you put it on there. Okay? So now if I go back to what did I want to do? Second table.
Table start on 3.
Okay, I should have all that data.
Okay, mine's on 24.4.
Well, starting on
Okay. All right. So let's just quickly go over these problems because we're going to do something new today. So the big picture for this lesson was being able to identify the holes and the asymptotes.